All right, let's give some feedback on the character tracker. Main just prints hello world. That's fine. Uh, so here's the description. This is also, oh my, fine. Okay, there we go. Here's the description. It's also available through the Google Doc that is available as an in-class exercise on the Google Classroom. But basically, we're tracking characters, where they show up, what pages they show up in books and things like that. So I'm going to go through now. There's a lot of things we could do to make this code better. I'm just going to hit like 5 of them. So here's the code. Probably take a chance to go through and look at this. Let me throw out some ideas. So first of all, map 1 and map 2 are terrible names for variables because you're inevitably going to get confused. What's map 1 mean? What's map 2 mean? I know it seems like a great idea because naming things is hard, but no. So let's rename this. I think I just right click on this and I go down here to rename symbol. This map is a map from character name to a description. So name to description. And that renames it, and it renames it everywhere, which is great. It's better than find and replace because it does it like it knows how to compile. This map is name to pages. So I'm going to do rename symbol. I'm going to call this name to pages. I could be cooler and do name and the number 2, but frankly, am I that cool? No. I have frumpy dad joke humor. I don't have like name 2 pages humor. That's not a thing I can get away with. Anyway, better names. Those names were terrible. Second thing to look at, and this is in no particular order. This is just sort of the order that we're going through things here. We've got title. We're setting title. That's fine. We're checking if it contains a character. Let's think about this. Chars.contains name. What does that mean? Well, what type is chars? It's an array list. That's a linear scan. Now, most books, what do they have? 10, 20 characters. That's maybe not a big deal. But if you're calling that method a lot, we might want to make that big O of 1. That's something to think about. I'm going to put this as a note. This is a linear scan. We may want to make, I'll just put this as a to-do, make more efficient. And I'll show you how to do that when we get to something else. Characters in order of appearance. This just returns characters. Well, that makes sense. This is a list. As you add things to the list maintains the order. That's fine. One of the things about this, does this have to be array list here, or could it be like on this? Because does this need to be an array list? An array list implies we need to get stuff out of the middle of it. But if we don't need to do that, then we could use a linked list. And not bother, because array list, it has to be a little bit bigger, might need to resize it. Linked list, you just add exactly what you need. And if all you care about is that they're in the right order, maybe that's okay. So I'm going to change this, since it doesn't have to be an array list. I'm going to change this to a linked, just a list. And then if we want to change this to linked list later, we can. Now, if the code still works with this being list, which it does, then that means that there was no reason that this absolutely had to be array list. And I say the code still works. Nobody's calling the code right now. Like I don't have a main method, or this isn't distributed to clients calling this, but I didn't break anything so far. And since I haven't published this API yet, it's probably good to keep things as general as possible. So I'm just going to make this list. That's probably fine. We're going to come back and fix this. Characters in order of appearance, that's probably fine. It's a collection rather than a list, but that's fine. A collection, you can just iterate through it in order. And what order is it in? Well, whatever order the list was, that's fine. Here we have get characters in alphabetical order. Now let's think about what this means. What are we doing here? This is a copy constructor. We're creating a new linked list. What are we giving it? Names to description dot key set. Well, what is names to description? Well, that's just the keys of this name to description. This is a map from the character name to the description of the character. Well, that's kind of interesting. Why do we have that at all? Can't we just use this list of characters? So we get this really interesting challenge here, because this list of characters should be all the characters, but the key set of this Key set meaning this is a map, which means it has keys and values. They call it key set because it's a map. The keys can't have duplicates. That's just the rules on maps. Values we just call values. It doesn't have to be a set because there can be duplicate values, but there cannot be duplicate keys. So, I mean, maybe we don't need this at all. Maybe there's a way to like get rid of this. Potentially. So here's my argument. This is a hash map. Well, I'm not going to use linked hash map. The right solution here is to use linked hash map. I am not going to use linked hash map. Instead, I'm just going to stick with a list, and I'm going to make a tree set, which is going to sort things into the... There's no linked tree set. Is there? There can't be. One moment. Yeah, not really. We're gonna just stick with, we're just gonna stick with this like this. We'll just keep this as a list. But here's the thing. If we need to get the characters in alphabetical order, and we're already going to be like creating a new list and sorting it, we may want to just store the characters in alphabetical order. Now, a couple notes about this. This is called a copy constructor. It's such a common operation to create a new collection class, array list, linked list, hash set, hash map, or not hash map, that's not a collection. Tree map, that's not a collection. Maps are not collections. Tree set, hash set, whatever. And then give it all the elements of something else. That's such a common operation that they have these copy constructors. This copy constructor exists basically so that we don't need to do this. Yeah, basically this, like, oh, create this and then add everything from there. Because I don't want to have to do that. So I'll just use the copy constructor, right? But it is weird that I'm like getting the name, the key set of names. I could just get characters. Those should theoretically have the same things in them. And then I'm sorting it and returning it. But if I know I need to sort it and return it all the time, like once I call this a couple times, I may as well just maintain something that's sorted. Watch this. So this is telling me characters. Let's do this. Sorted set of character names. Let's try this. Private. You know what? Watch this. Watch this. I just thought of a better way to do this. Why make this a hash map? You know what? I don't want to overcomplicate things. Sorted map. No, sorted set of character names. Let's do this. And we'll do private. Really? Set of string. There we go. Sorted characters is new tree set. Let's fix the quick fix. Import. Quick fix. Import. Got it. All right, good. Sorted characters. Now, tree set. What's a tree set? It's basically a binary search tree. So add, remove, contains, or log in. And that, well, that's basically that. But it's sorted because it's a binary search tree. So it's not big O of 1, but it's log n. That's pretty fast. Because remember, log n of 1,000,000 is like 20. Log n of 1,000,000,000 is like 30. So let's see what that means here. So what do we do here? Well, guess what? We just return. Really? Copilot has gone wonky on me. Return. No, just return. Yeah, just return this. That's it. Done. Because this just needs to be a collection. Well, guess what is a collection? A set. So now we're done. Now, we do have this problem. It's a subtle problem, but it gets back to this challenge here with contains character and get characters in order of appearance. Adding characters, like add new character, which just add characters here. Now we're adding them as well to sorted characters. But let's think about this. What if we add Bob? We add SpongeBob, then we add SpongeBob again. SpongeBob's going to be in the list twice because lists can have duplicates, but in this once because you can't have duplicates in here, right? You can't have duplicates in a set. So probably what we actually want to do is something like if it's if sorted chars contains name, and I don't want to return. That's not the best suggestion you've ever had for me. Copilot, I want to throw new legal argument exception, character already exists. Otherwise, add it to both places. So now that list, which can contain duplicates as a data structure, now cannot contain duplicates. And this contains method is as efficient as possible because you're using the binary search tree, which is log n. So if you have something with 1 million characters, which is a lot, you probably don't have books with 1 million characters, but 1,000 characters, well, then you only have to check, instead of checking all 1,000 characters, you only have to check 10 because 2 to the 10th is 1,024. So log n of 1,024, log base 2 of n is about 10. Right. So that's pretty efficient. And I'm just picking a legal argument exception because we've given an illegal argument to the method. There's other methods there's other exceptions we could choose, but that's just one I've picked. So this solves multiple problems. We can't have duplicates. We just have a sorted collection of character names sitting around. And then we have another collection of character names that's a list, which has the order in which they appeared. Boom, I've got it. I just realized that we don't need this list at all. I'm such a dope. No, I do. Because there's no such thing as a linked tree set. What would that even mean? There's no linked tree set. We need 2 lists, the list and the set. Boom. Don't get overcomplicated, Spacco. Just stick to the basics. Anyway, so this makes it better. Now we can't have duplicates. That's good because you don't want to have the same character in there a couple times. Now this contains character, which was linear. Guess what? We can now return to this. You want to know if it contains a character? Let's just go with sorted characters. That's going to be a lot more efficient because, again, that's log n rather than big O of n. So that, again, for a book with characters, maybe there's only a few dozen characters. Do we want to look through 50 things or do we want to do log base 2 of 50, which is like 5, between 5 and 6? That's not going to break the bank, but whatever. We're using more efficient data structures. We have the data structure now because we need the name sorted, and that's fine. And now we pay the cost. When we add a name, we have to maybe update the binary search tree, which is log n, but it's already sorted. So if we're just like, give me a sorted list to iterate through, it's already there. We don't have to resort it n log n every time. Okay, so boom, add description and update description. These do the same thing. That is not great because what happens if we already have a name and a description in our data structure? Well, if we try to add another description, it just overwrites it. But if I say add description, well, that implies that it's an addition, that I don't have that character and I'm just adding their description for the first time. So that's like a little bit of a challenge. So probably what I want to do here is I want to say if oh, my phone's ringing. Okay, I'm gonna have to pause you for a second. Hold on. All right, so I can check. Wait a minute, hold on. If name, come on. There we go. So if it contains it, throw an exception. You already have a description for that character. Otherwise, we put it in there, right? So this way you can't add the description twice. Now, there is this weird issue, add description, where like, add description, like what are we really talking about here? We already have the sorted list of characters, and we also have a list of characters, and now we have this map from the name to the description. So we've kind of got a lot going on here. I'm going to show you a way to take this and stick them together, but I'm not going to do that just yet. So yeah, so this at least means we'll crash, right? If we try to add which makes sense. If I add the character and then I do a bunch of other stuff and then I try to add the same character again, I don't want to overwrite the data that was in there before. Or even worse, if somebody else adds the character and then I try to add the character, I don't want to overwrite their work, right? I'd rather get the exception. So this at least makes sure I get the exception. For update description, this implies that the character's already been added. So here we would just do the opposite. If it doesn't contain the name, crash, right? That makes sense too. So this at least gives us clearer semantics for add and update. If you're adding, you're assuming it's not already there. If it is there, crash. If you're updating, you're assuming it already is there. And if it isn't, crash, because both of those indicate that your assumptions by what method you're calling are not correct with the state of the data. You should immediately crash so we know what went wrong. And we have these like relatively good descriptions here. Okay, so add character on page. This is fine mostly. This is this variable length list of arguments. It basically takes these and sticks it into an array. I'll show you in main what this would look like. So we would say, there we go. I would make a character tracker. The Hobbit. Okay, fine. I'm going to be a wise ass and pretend Merlin was in The Hobbit. Yeah, no, guess what? Merlin's not in The Hobbit. I'm being a wise ass. Gandalf? Oh, no. Tracker dot add, no, tracker. What is the method called? Get at, yeah, this one. Add characters on page. Okay, Merlin shows up on page 1, 2, and 5. Right. And I could also say, oh, you know what? Fine, I will add Bilbo. SpongeBob is also in there. SpongeBob only shows up on page, just at the very end, SpongeBob shows up and like kills a troll and then disappears. Right. So I can have as many things separated by commas as I want. I can literally have 0 too. Believe it or not, this is legal. Right. This will just have nothing. This will actually work. It'll just create an array of size 0, but I want to have the 99 in there. So now in character tracker, pages just gets turned into an array. So this iterating through is just iterating through an array. Now this, if it's not the case that my name to pages contains the name, put a linked list in there, that can only happen once. So I may as well just do this before the loop. It's not wrong to have it in there, but it's not necessary. So I may as well put it here. And then we're adding the page. That's fine. Now get characters on page. This is implying that we also need to map from integer to a list of characters that show up on that page. So if we look here, we're going from the character name to a list of pages. So we're storing that, but we need to be able to look up from page to a list of characters. Well, this is a lot of work because here I'm iterating through every entry that's in here. And then for each of these, I'm getting the value, which is a list, and checking contains. Contains on a list is linear, right? So this is linear. This is linear. This is like, it's not n squared because it depends on sort of like how many pages each character shows up on. But if each character shows up on m pages, it's n times m, not great. So here's what we can do. If we're already storing it this way, map of all the characters that appear in a given page. Great. This already knows what I want. Page to names. Wow. Go you. And does this need to be a list? This actually could be a set, believe it or not. It could be a set because we probably don't want the character in there multiple times. We just need to know, does the character occur on the page at all? We probably don't want in there 16 times if the character gets mentioned 16 times. We just want it to be once. So we could be a set. I think so. And so now, where's that method? This method here, right? What are we doing? Well, we're going through each page for a given character, because we're saying that this character occurs in all these pages. Well, for each of those pages, if it's, yeah, there we go. If it's not the case that it contains the page, then that means there's no set for that. Put it in there. This is doing a tree set, so it'll be sorted. Do we care about that? Probably not. I'm going to make it a hash set just so it, really? We don't have hash set anymore? Really? Can I get that? Import. There we go. Boom. Yeah, and then we'll put it in there. So now we have it in both directions. What does that mean? That just means down here. Oh, guess what? Return. Okay, cool. That works. And I can just delete literally all of this. Love it. So what's going on here? Well, this getter default means get the value associated with this page, which will be a collection of strings. Or if we can't find it, then just return an empty collection. That's correct, because well, it's potentially correct. If there's some questions here. If we ask for a given page number and we get, and no characters are mentioned on that page, what do we want to get back? Null or an empty collection? And you could argue an empty collection because it's legal for there to be a page that has no characters on it. The title page may have no characters on it. Page 50 may just be description of scenery with no characters ever mentioned. Who knows? You know, so this is a little bit debatable. Do you want null? Do you want to, you probably don't want an exception, because asking for the characters on a page where there are legitimately no characters is possible for a book. So you probably don't want an exception. It's not wrong to ask for it, but do you want an empty set or do you want null? It could go either way. It's really up to you. I just want to show, and GitHub Copilot really wanted to show you this getter default to show this, but this is so much easier than having to write a bunch of code. The complexity is when you add the data, not when you look up the data. So already, just with this pretty simple code, which would have worked reasonably okay before, but it had a lot of edge cases. You had potential for duplicate entries. You had to do extra sorting. You had to do a bunch of extra work to look up through a list of values to find what keys are in the right places. By sort of changing this around, we save a lot of work. Now, there's one other thing I wanted to show you, and this will be the last thing I show you because this video is starting to go a little bit long and I got to go pick up the kids. This sorted character tree set, I don't think we need it. Watch this. This name to description. Let's just, this has all the character names. Let's just make this a tree map, right? Which we will have to go import. Tree map means it sorts the keys. So the key, because it's basically a binary search tree for the keys, and then the values are just attached to the keys. Now what I can do is I can just literally get rid of this. Just gone. Now, what does that mean? Well, contains Boolean contains character. What does that mean? Well, I'm just going to do name to description contains key. And that's still log n because it's a tree map. So name to description, the keys of name to description is a sorted set of essentially a tree set of all the character names. So I've got it. You know, we got it. Okay. So, what else do we want to do? Get characters in alphabetical order. This would just be names to description.keyset. Boom. Got it. This one here is just name to description dot contains. Actually, for this dot contains, we could actually be fancier here and just say contains character for the name. Right. That'll tell us if they, in other words, we can call our own API methods. Yeah, I like this more because now, however we implement these methods is fine. And then for this, we don't need to really add it to anything. Well, we kind of do for adding the character. What do we add this to? We add this to name. Yeah, name to, well, I did run into a bit of a challenge here, which is that can we have a character name with no description? Damn it. I really screwed the pooch on this one. I didn't really think it through. Right, because now what do I put with this? If I'm going to use the set, if I'm going to use the keys of this to mean something else, let's undo everything, Spacco. Undo. What are you even doing? Why are you trying to get clever? Just have the extra stuff and don't worry about it. Yeah, just have this and just undo that. It's fine. It's fine. This is fine. We could probably go and like make this slightly more efficient, but whatever. Now, here's the okay. You probably don't trust me after I did that wrong last time. I didn't think it through, but I found where it was going to cause a problem, and then I noticed it, and then I backed up, so it's fine. Let me just tell you one other thing. So, looking at this, I'm like, okay, name to pages, page to names. I've got a name of the character. I've got a list of the names and things like that. Maybe I just want to have a class for character, which has the name, a set of pages where they occur, stuff about the description, you know, and the description maybe is like a list of different descriptive passages that show up at different places. Cause maybe early in the book, the character is described as like, a total badass with a heart of stone. But then after they rescue the injured puppy, find that they secretly have a heart of gold or something like that. But you don't find that out until page 75. If you told you that right away, they wouldn't be as big of a character arc. So we sort of like see that sort of thing. So that's a thing we could do. We could try to integrate that concept. We also could have a maximum and minimum page. So if we try to add like, hey, I'm calling, where's the page, ... I'm calling this method with page numbers that don't make any sense. Well, maybe that's a problem. This here, maybe this, instead of being a list, maybe this should be a set, right? Do we have a list of pages? Well, that could contain duplicates. Maybe we don't want duplicates. That's a pretty easy fix, but that's a thing we could do. So there's a lot of different things we could do to try to make these small improvements. And these are the kinds of things you want to think about the data structures and about, we also don't have a method like given a character game, give me a list of pages. We probably should add that method. There's a lot of these little nuanced things that we could try to fix. Okay. Anyway, that's what I've got. Good job.